Good morning, students. Are you able to hear me?
Yes, ma'am.
No. Then we start. So yesterday we started with electric and hybrid vehicle architectures. So in that we have completed hybrid vehicle architectures. So basically hybrid vehicle architectures is nothing but the hybrid vehicle drivetrain is basically discussed. Okay, how it is different from the conventional IC engine vehicles, the drivetrain used in hybrid electric vehicle. What are the advantage and drawbacks? What are the different architectures? What do you mean by series, parallel or parallel architecture? Okay, so these things we have covered in the yesterday's lecture. Today we'll discuss electric vehicle and then we start with the second unit. Okay. So as we have already discussed, the advantage of electric vehicle is basically zero emission, high efficiency, and as the IC engine, electric vehicles are those which are completely operated based on the battery pack. Okay, and hence there doesn't exist any IC engine. Okay, so engine itself is very heavy, and as the engine has been removed, so most of the vibrating parts like piston, crankshaft, uh, camshaft, all those mechanical parts which are responsible for generating noise and vibrations will be reduced. Okay, and because of that, electric vehicles are having no vibrations. Okay, and they perform smoothly. So how we can just relate your conventional vehicle with the electric vehicles is something. This is the analogy represent in simple words. Okay, if we want to compare our electric vehicles with the conventional vehicles, we can just directly relate the fuel tank can be replaced by the battery bank. So fuel is the thing which is responsible for combustion and generating the power. Okay, so required power, it depends on the amount of fuel and air. So the same thing, whatever is by burning this air fuel mixture, we are getting the power, required power. So that is now can be obtained from the battery bank. Okay, and the second thing, directly your IC engine are represented or can be just, it can be related as the electric motors. Okay, so the required power or torque can be generated using the electric motor which are driven by this battery bank. Okay, and this is the simple analogy or conversion of your conventional IC engine vehicles into electric vehicles. Though just using the same analogy, initially the electric vehicles are just formed. Okay, that is, electric vehicles are manufactured simply by replacing your IC engines and this fuel tank by battery bank and electric motor, and no other modification has been done. So when the first electric vehicle has been generated, that means the complete drivetrain is as it is, only the IC engines are replaced by motors and battery pack. Okay, and because of that the vehicles are very heavy. Okay, so weight of those vehicles has been increased because nothing has been modified except the battery pack. Okay, and the motors has been added. Okay, so those are giving us less efficiency, lower flexibility in case of just controlling the speed and all those things. Okay, and just to avoid all these drawbacks, the electric vehicles are modified something like this. Okay, this block diagram represents the modern electric drive. Okay, so still, if we are considered the electric vehicle, those are coming in market uh, nowadays. So those have been modified a lot as compared to this diagram also. Okay, So in general, the modern electric vehicles, how they works, or what will be the flow that can be just understood from this particular block diagram. Okay, here this block arrows are representing electric links. So this is representing your mechanical link, and these are the control signals. Those are generated to control the operation of electric vehicle. Okay, so basically, as we can see, it consists of three different systems, subsystems. Okay, so one is electric propulsion subsystem, another one is energy source subsystem, and the third one is the auxiliary subsystem. Okay, so the various components of these three subsystems can be represented. For electric propulsion, it is consisting of vehicle controller, electronic power converter, okay, electric motor, and it is the motor is connected to mechanical transmission to drive your wheels. Okay, so what is the job, or how this particular subsystem works? Okay, so basically it works based on the input which is obtained from this brake and accelerator. Okay, so it will sense the position of your brake and accelerator pedal, and those control signals will be given, can be read by this vehicle controller. Okay, and that vehicle controller generates the control signal for electronic power converter. Okay, so the control signal which is given to this electronic power, based on this control signal received from the vehicle controller, your electronic power converter regulates the power between electric motor and the energy source. What do you mean by that? Is this particular power converter decides how much power is to be transferred to this electric motor to drive your vehicle at the required speed, and based on that, what is the input power it has received or it has generated, and whether there is some power that can be transferred to the energy source which can be used for charging of the vehicle. So that is nothing but, so it is taking decision of transferring power to electric motor as well as energy source. Okay, so the backward power generated due to braking, that is regenerative power, can be stored in this energy source. Okay, so that is again diverted through this power converter, which will be given to this energy source. The energy which is generated during the braking will be again connected to this energy source through the electronic power converter. Okay, so this is one way of, or this is how your this particular subsystem works. Okay, then the energy management unit, what is the job of this particular unit or energy management system? So that energy management unit works with the vehicle controller. It works in coordination with the vehicle controller, okay, to control the regenerative braking and its energy recovery. Okay, so whatever is the power received from this energy source, it will just decide how much is to be used for refueling, that is for charging your batteries. Okay, so based on the input obtained from this vehicle controller and the control signal that is obtained from the energy source, it is deciding the power that can be used for recharging your batteries, okay, in the regenerative braking. Okay, so this is how your energy management system works. And what is this auxiliary subsystems? Okay, so auxiliary subsystem provides the power which is required to drive the auxiliary systems in the vehicle. So that can be again managed from the energy source, that is from the batteries. Okay, so either from the power that is received from electronic power or from the power that can be obtained from the batteries. Based on that, your various auxiliary systems like lighting control, hotel climate, means it is HVAC actually, heat ventilation, air conditioning system of your vehicle, power steering, and other interior light, door control. Everything can be that comes under your auxiliary power supply, and that can be controlled through this auxiliary subsystem. Okay, so this is how your electric vehicles works. Okay, so with the help of, or it can be broadly classified into three subsystems, and in coordination with your electronic power converter and energy source, all the power management has been done. Okay, and your vehicle is responsible to drive. So this is regarding your modern electric vehicle drivetrain. Okay, so this we already discussed. The same thing has been represented over here. This also we have discussed. Okay, now coming to the electric vehicle configuration, there are different architectures, again we can say, or the configuration based on where your this particular motor, or how the driving motor is connected to the wheels. Okay, so as I said initially, it is simply replacement of your IC engine with the motor. So this is representing your the primary electric vehicle architecture. Okay, where these clutch plates and gearbox, everything is existing, differential, all these parts are there. Only your IC engine has been replaced by the motor, and motor is responsible to drive all this drivetrain. Okay, including your clutch pack, gearbox, and that gearbox is connected to differential, and differential is responsible to decide the speed for individual tires, wheels. Okay, so this is your first architecture. Actually, it has been modified where there is no need of clutch plates. Your motor is sufficient to drive, or just get motor can be controlled can through the programming, and there is no need of these clutch plates. Basically, clutch plate is required to engage and de-engage. Okay, and that can be controlled by controlling your motor. Okay, and hence this particular system or the clutch plates has been removed, and motor is directly connected to the fixed gearbox, or gearbox we can say, and which is connected to again the differential. Okay, so this is how your architecture for electric vehicle has been modified. Again, this is something, there is no need that this motor should be connected to through this gearbox, or your motor can individually um, just control the vehicles. Okay, the motor can directly control the vehicles, and hence this particular part is directly, or motor is directly connected to the wheels. Okay, but a single motor is used to drive both the wheels, and hence we need the differential here. Okay, so directly your motor fixed gearboxes that consist of your differential. So motor is directly controlling your differential here. Okay, and that differential is used to give different speeds to your these left and right wheels. Okay, so this is how your this structure has been modified, where initially clutch pads are removed, then the gearbox itself is removed, and directly your motor is driving the differential. And after that, it has been observed that we can use individual motor for each wheel. Okay, and individual wheel speed can be controlled by controlling the motor speed. Okay, so individual motor based on the position, steering position, based on the position of individual wheel. Okay, so your motor speed can be controlled, and likewise we can control individually each wheel of the vehicle through different motors. And hence nowadays the architecture, electric vehicle architectures are every wheel is having a separate motor to drive that particular wheel at different speed. Okay, so this is the latest or modified, not latest. Okay, so this is the modified version of this. And again, in the newer one, that fixed gearbox is also just replaced. Okay, so this is almost same as that fixed gearbox. Gearing is it is just aligned to your wheel itself, and here the last configuration is representing that directly motors are driving your wheel. There is no need of any gear also. The motors are designed such that your electric motors are sufficient to drive the wheels. Okay, so this is how your electric vehicle structure is getting modified uh, eventually, and finally everything can be controlled only through the battery packs and the motors. So most of the mechanical components has been replaced by electrical and electronic components, and based on various signals obtained from the sensors. Okay, we are controlling, or ECUs are controlling the motor speed, angle and everything. Okay, so this is all about your electric vehicle, and this is the end of your first unit. If you are having any doubt, you can ask.